Some things to know about geometric solids. First of all, geometric solid in math, when they talk about geometric solids, those are three-dimensional shapes. And rather than have you try to draw them, rather than you have to try to draw them, I figured I would just give you the list so you can see them there. Okay? Let's see exactly what they ask you there. And you've got these ones that you should know. I guess we should probably talk about what's the difference between a polyhedron and a not a polyhedron. For something to be a polyhedron, to be a polyhedron, every face must be a polygon. I suppose before we talk about that, we have to talk about faces. Well, faces are the sides. We'll get to that in a little bit, a minute there. So if you look at the three that are, or the four that are polygons, and compare them to the ones that aren't polygons, what would be like the 6th grade way to say, to know the difference between what's a polyhedron and what's not? Polyhedrons, or the ones that are not polyhedrons, what do you notice about these three shapes that are not polyhedrons compared to the 3 or the 4 shapes that are polyhedrons? Zach? Yeah. Not polyhedrons have curved surfaces. They have some round pieces. The non-polyhedrons have some round pieces, where the polyhedrons are all things there. And then if you look at what would be the difference between a prism and a cube. Well, let's do a cube first. How do you know if something is a cube? Because a cube looks awful lot like a rectangular prism. A cube must have what? Jordan Shaw.
4 sides.
Now, all these, by the way, have 6 sides. These two both have 6 sides. Cubes and rectangular prisms all have 6 sides. What's special about a cube, Sam?
All sides must be equal.
Kind of. A better way to say that, Peyton?
All sides have the same size.
Yes, all sides have to be, Tyler?
Squares.
Yeah, a cube, all sides have to be squares. Which is the same thing as saying they're all equal, because they are all equal, but they all have to be square sides to be a cube. Okay. I don't know if it actually, we don't talk a whole lot of, and the one thing to understand and know is that prisms are named for their bases. Hence the reason why this shape here, you can kind of see on your paper the base side is shaded. The base of this side is, well, let's do this. Because you're 6th graders, here's the question. What makes a base? What is a base in a prism? Question mark. Who can tell me what makes a base? Now, usually, let me help you out with this. Generally speaking, when you talk about bases in real life, you talk about the side something is setting on. Things usually set on their base. That is not the case with prisms. How do I know what shape is the base? And I wouldn't expect you to know this. That's why you will learn something new today. Being a smart, intellectually sound 6th grade you are. I like to, and I've come up with this one myself, that's why I'm so eager to tell you this. I like to think of the loaf of bread theory. And by that, ask yourself this question. How would I slice the prism so my slices all were the exact same shape. In other words, let's look at this lovely little gem right here. Okay? If this was in fact your loaf of bread, you could go to the store and buy a loaf of bread that looked like this. You were trying to make a sandwich out of this loaf of bread. What way would you slice it so that when you cut your two pieces of bread, they would match up like a sandwich should? See, if I took this thing and it was set like this, and I started slicing it like this, all of my pieces of bread will be rectangles, but those rectangles keep getting bigger the closer I get to the middle. So if I tried to make a sandwich out of it, you're going to end up with one rectangular piece, and the next one's either going to be bigger or smaller. So either your meat, your mustard, your mayonnaise, it's all going to fall out because they're not going to match equally up. If this was my loaf of bread, Max, I'm going to slice it.
You're going to slice it from the top on the side. So
Like this?
So, no, on the side like this. Yeah.
Like this?
No.
Like diagonally? No.
No,
I'm going to slice it like
that, yeah.
and every shape is going to be this exact size, which is a, what is this shape? 6 sides is a,
Hexagonal.
this shape is called a hexagonal prism because the shape of its base is a prism. Okay, and that's what the whole loaf of bread theory is. Okay, if I gave you, well, here's one from the book. Okay, the reason this is called a triangular prism is because if you were making your sandwich out of this, you wouldn't want to slice it like this because again, you keep getting rectangles, but they get awfully small when you get down to the end here where your little piece of bread would be about whatever, 1/8 of an inch thick. You're going to slice the bread so that it's this equilateral triangle. That's why it's called a triangular prism. Now, a rectangular prism is very unique in the sense that what is the base of it? With a rectangular prism, you get your choice because there are 3 different sizes I could make my sandwich. Every side could be classified as its base because I could slice it like this and get all of these sides for my sandwich, or I could slice it like this and get all of these squares for my sandwich, or I could slice it like this and get all these little rectangles. Technically, a rectangular prism has 3 different bases that you can call it. Okay. So there you go. That's what makes a rectangular prism. Now, what about a pyramid? What's special about a pyramid? By the way, pyramids are also, you can't really use the loaf of bread theory for the pyramid, per se. But what makes a pyramid? Pyramids come to a point. And the base is always opposite that point. Point, base is opposite. And technically, a cylinder is really a circular prism, but we call it that. Same thing, a cone comes to its base. A sphere is just the same thing as a ball. Now, with that, ladies and gentlemen, since you are 6th graders as well, I'm going to drop down here, and you can do this. If you're trying to draw a prism, let me help you out with the easiest way possible to do that. Let's say I wanted to draw a, let's go with, what's a 5-sided shape? Let's say I wanted to do a pentagonal prism. Now watch how easy it is to draw this prism. First thing is start off with a pentagon. Here is my, maybe I should blow this up. Oh, that thing will work right now. Start with my pentagon. It's a nice 5-sided shape, is it not? Got my pentagon there. If you then draw an exact same pentagon like that off to the side here, oh, what best you can anyways. I know it's not easy to draw. My two identical pentagons, if you then connect the corresponding corners, like I go from here to here, this corner and this corner are the same, this corner and this corner are the same, this corner and that corner are the same, and this corner and this corner are the same. You may not see it now, but that is going to be my prism. What I need to do is get rid of some of the sides that you shouldn't be able to see. Let's say this was my face. Okay, I would not be able to see this line, so I make it a dashed line. I would not be able to see this line, so I would make it a dashed line. All this stuff is in the back there. Maybe it's magically appearing for you, maybe not. This will make it really magically appear. Let's shade it a little bit. This is my front. This would maybe be one side. What kind of goofed it up is how thick my lines are back there. And this would be my other side.
Oh, wow.
Can you kind of see it now?
Oh, wow.
It's a pentagon and a pentagon, and you draw the lines. And we have to define this. With prisms, we have things that are called faces. I have faces, I have vertices, and I have edges. And what's the difference? Faces are the mathematical way to say sides. How many sides does this shape have? And if you're looking at my hexagonal prism there, how many sides does that thing have? Anybody want to speculate? We could number them, I suppose. I have this front, which is 1. I've got the same space back here, which is 2. I've got this green side, which is 3. The yellow side, which is 4. I've got this side back here that you can't see, which is 5. I got this back side over here, which is 6. And this bottom side here, which is 7. It has 2 pentagons, and it's surrounded by 5 rectangles. So this thing has 7 faces, or 7 sides. Vertices are the points. And if I'm looking at the points on my pentagonal prism, that would be here's 1, here's 1, here's 1, here's 1, here's 1. And then the ones on the back side, there's 1 there, 1 there, 1 there. Where's the one right here, and 1 right there. How many vertices does this thing have? It has 10. And an edge is where it's kind of a corner where 2 faces meet. Where 2 faces meet. And those would look like this. What color should I make them? Let's go orange. Okay. 1, 2, 3, 4, 5. I've got the ones on the back. 1, 2, 3, 4, 5. So there's 10. Then I've got the ones that surround it. 1, 2, 3, 4, 5. How many edges? That boy has 15 edges. 15 of them. There are 5 right here. There are 5 that make up the back, and then the 5 that trump thing. Maybe it'd be more clear if I asked you this. So here's my hexagonal one. How many faces? We really got to stop with the steel jugs there. If you cannot control your water things, please don't bring them, or bring plastic or something that's not going to make that much noise. You know, when I was a kid, you know what we did when we wanted water? We got out of a drinking fountain. I'm relatively sure you're not going to dehydrate in the span of 45 minutes of math class. How many faces does this have? You've got this face right here, which happens to be missing. This face right there, which is right there, that's 2. And then how many faces make up all the sides? Kelly, will you please stop? Will you either pick it up or do something with it to stop making noise with it? You've got this face, that's 2, and then how many faces surround it? 6 more. So this has 8 faces. How many vertices? 1, 2, 3, 4, 5, 6 here, and 1, 2, 3, 4, 5, 6 there. How many edges? 1, 2, 3, 4, 5, 6 here, 6 there, and then the 6 that go around the outside, 18. Now all rectangular prisms have the same number of sides, faces, and edges. Faces on a rectangular prism would be, how many sides are in a box? On a cube, 6. How many edges? No. There's 4 here, 4 there, and 4 that surround it, 12. How many vertices? 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. Frankie.
The edges, can't you just multiply it by
Not always. You gotta be careful because then when you start dealing with things change a little bit when you deal with pyramids. Let's look at a pyramid here. How many faces would this pyramid have here?
4?
4, because you got the 3 that surround it at the bottom. How many vertices? 1, 2, 3, 4. Just 4. 1, 2, 3, 4. No other points. And how many edges? 1, 2, 3, 4, 5, 6. So you can't just make a global rule about multiplying or dividing and doing any of that sort of stuff there. So shows